based on finding the surface area of combined solid, and the second one completely based on volume of combined solid. So yeah, for solving the question, you need to recall all those formulas which you have done already. And yeah, a little bit you need to have idea about the formulas as well. So just a moment, let me explain it. Let me take the formulas first, then we'll be solving the questions. So first formula is, what is the surface area of cuboid? Who will say what's the formula for surface area of cuboid?
2 times LB plus BH plus HL.
2 times length into breadth plus breadth into height plus height into length. Yeah. So I'm going to draw the cuboid and we will see from where the formula is coming. A little bit like properly you need to have an idea about the formula as well, or maybe about the shape, so that you can think about like the questions require proper understanding over here, not just the formula based question you will see over here just like class 9. So here, surface area of cuboid. Okay, surface area means area of all the surfaces. Whatever surfaces you can see over here, area of each and every surface added together, it's called the surface area. Okay, this surface area, the formula which is written on the screen, actually this is the formula for total surface area of the cuboid, but we call it surface area as well. So this surface area contain area of all the surfaces. This surface, area of this surface, area of that surface, which are exactly same, okay, identical with each other. Area of the bottom surface, area of the top surface, these two are exactly same, identical with each other. Area of the front surface, okay, which now you are not able to understand, but there is a front surface as well, a rectangle you are having at front and a rectangle you are having at the back. Yes or no?
Yes, ma'am.
Okay, so these many surfaces are we are having over here, and all the surfaces areas added together is giving us this formula: 2 times length into breadth plus breadth into height plus height into length. Okay, if you will focus carefully, so the bottom one, it's a rectangular sheet, the bottom one. Okay, it's a rectangular sheet just like this, uh, just like this. I'm talking about the bottom one. It's a rectangular sheet. There must be length, there must be breadth. Okay, before starting with this one, suppose I am drawing a shape which is rectangular. And if I say that this is x, this is y, what is the area? So you will say x into y. Yes or no? Right? Again, if I'll draw a rectangle and I'll say this is k, this is b, what is the area? So you will say k into b. Making sense?
Yes, ma'am.
Okay, same thing we'll be using over here, the bottom rectangle, the orange one, which is at bottom and at the top, both the rectangles are exactly same. So area is what we are using, length and breadth. Okay, L and B, it's L is the length, B is the breadth. So the area for this bottom rectangle will be length into breadth, and for the top rectangle, area will be length into breadth. Similarly, we are having the left side rectangle and the right side rectangle. So you can see a rectangle over here like this. Okay. What about the area of this rectangle? I'm talking about this green color rectangle. Okay. What about the area of this rectangle? So here two things are involved. One is which we are calling as a B. okay, breadth, and another is working as a height, okay, height of this cuboid, say. Okay, one of the side is B, another side is H. The way over there you are saying, if the one of the side is X, another side is Y, area is X into Y. The way over there with the example you are saying, if one of the side is K, another side is B, area is K into B. Similarly here I want you to say, if one of the side is B, another side is H, area will be B into H. Making sense?
Yes, ma'am.
Okay, similarly, that right rectangle also area will be same, B into H. Okay, and now we are left with the black one, the front one, and the back one. So far, is it making sense? Is it making sense so far to all of you?
Yes, ma'am.
Okay, now this black colored rectangle, which is the front one. Okay, the front one and the back one. Over here, what is used? See the actual figure, actual figure. Side which you are calling as a L, that is used, and the side, okay, H, which you are taking as a height of this cuboid, that is used. Okay, so L and H is used, so we will be taking area will be L into H. Okay, and at the back also exactly same rectangle we are having, so over there as well area will be L into H. Now the total area, surface area means area of each and every surface added together. So we realize the bottom rectangle, okay, it's having area this one, and the top rectangle is having area this one. Then we realize the left rectangle and the right rectangle is having the area this B into H and B into H. Then we realize this front rectangle and the back rectangle is having the area L into H and L into H. And are you realizing the formula which you are using from lower classes, that formula actually came from here? Yes or no? Is it making sense?
Yes, ma'am.
Okay, so this 2 times length into breadth, breadth into height, height into length came from here only. Area means total surface area, all the surfaces. Okay, one by one we have found the area, all added together is the surface area of the cuboid. Now instead of cuboid, if I'll draw a cube, if we are having a cube, you can understand. Okay, here A, the length is A, the width is A, okay, and the height also A. If all are just I mean same, then area will be exactly like that. Okay, the bottom circle, the bottom, this is square sheet area A square, the top is square sheet A square, okay, left is square A square, the right is square A square, the front is square A square, okay, the back one square A square, and from here the area of the cube formula is 6A square, surface area of the cube. Yes or no?
Yes, ma'am.
Is it clear so far to everyone? Clear? Now cylinder. Suppose we are having a rectangular sheet, okay, where this is the length, this is the breadth. Area of this sheet is length into breadth. Now I am going to convert this sheet in the form of cylinder like this. You understand, we will just fold it and it will take the shape of cylinder. Now L, this L became 2 pi r, yes or no? Because it has taken the shape of this circle. Okay, so L and the circumference of the circle is the same thing. Yes or no?
Yes.
And the breadth is now working like a height of this cylinder. Now the area length into breadth which you called just now, that L became 2 pi r. and breadth is nothing but just height. Hence, for cylinder, we say the surface area, I mean the curved surface area, just the curved surface area is 2 pi RH. Yes or no?
Yes.
Here you will always see the question will be talking about right circular cylinder, right circular cylinder. That means if you will start placing a bangles, okay, you have to place all the bangle having same measurement, then only you will be getting a cylinder, okay, a straight cylinder. Otherwise your cylinder may look like this as well, which is not at all right circular. I mean, it is broader over here, maybe, and just getting narrower like this. Okay, not that much, but little bit. Okay, like this one. It's not a right circular cylinder. This type of shape you will be getting when you will place a bigger bangle. Okay, then maybe bigger again, then smaller, then smaller, then smaller. Then your cylinder will be. It's not right circular cylinder. In right circular cylinder, the radius you will take or the diameter you say anywhere you will take, it will always be same. Making sense? Making sense?
Mm.
Okay, that's called right circular cylinder. And while talking about the cone as well, you always see right circular cone. Okay, right circular conical shape. So that means our cone looks like the birthday cap, that cone we are having, which is at first there is a circle like this, and then there is a perpendicular over here. Suppose I am taking a circular sheet and I'm just creating a perpendicular over here, and then here I am dropping a conical tent. Okay, then you can understand you will be getting a right circular cone. Yes or no? This is a right circular cone. However, you must have seen your conical shape like this as well. Have you seen? It's not right circular. Clear?
Yes.
Okay, now this is the surface area, curved surface area of the cylinder, that is 2 pi RH. The formula for curved surface area of the cylinder, are you able to recall, everyone? It was just 2 pi RH, curved surface area I'm talking about. Okay, now if I'll place a circular lid at the top and a circular lid at the bottom, okay, it will be, we while talking about the area, we have to take area of each and every surface. So we will find there is a curved surface, there is a top surface, there is a bottom surface. Okay, that's called total surface area of the cylinder. And for total surface area, are you able to recall the formula was curved surface area plus 2 pi r square? Yes or no? Total surface area of cylinder is equals to the curved surface area, that is 2 pi RH, plus the upper circular lid's area and the bottom circular lid's area, pi r square will be 2 pi r square. However, here you can take 2 pi common, r common, and in the bracket we will be left with h plus r. Clear? Is it clear?
Yes.
Okay. So yeah, surface area of the cuboid, cylinder we are done. Now cone. For cone also, okay, this is a conical shape, right circular cone. Okay, for cone, actually, when we will open this cone, no, we will be getting a sheet like this. And actually, what we do, we take the area of a triangle over here and area of this triangle over here, this triangle, so many, we just divide it in the form of triangles. And actually the formula It's coming from there only, pi r l. Okay, this formula is coming from there only. You will be taking area 1 plus area 2 plus area 3, all the triangles area when you will add. Okay, it will be everywhere the height of the triangle will be nothing but just the slant height. Okay, so when you will do for area 1, 1 by 2 into base. Okay, you can say base is OA, base into height actually will be slant height. Okay, this slant height, when you will actually take a paper, will make a cone and then will open it, height, and this L will work like a height for each triangle. However, this formula is not important for you, but since I'm just explaining you other formulas, let me show you from where this formula is also coming. Quickly, we'll be starting with questions. So this L, when I'll take the area 2, they are also 1 by 2 into base. Suppose the base is AB into height. Okay, this way it will come. And when we will do area 1 plus area 2 plus area 3 plus area 4, just like that. Okay, we will be getting 1 by 2, 1 by 2. Okay, OA into L plus 1 by 2 AB into L. And if we will take 1 by 2 L common, we will be left with OA plus AB. Actually, nothing but just the circumference of this circle. Okay, OA plus AB, and then the remaining bases and all. Nothing but just the circumference of this rectangle. Circumference of this circle. Okay, where this will get cancelled out, and hence the formula pi RL, which you have always learned. L is the slant height. Okay, perpendicular height, when we have to take, we always take the height like this. This is the perpendicular height and that is the slant height. Is it clear so far to everyone?
Yes. Yes.
Okay, this is the formula for curved surface area of cone, pi RL. We also call it lateral surface area. Lateral means all around it. Lateral means all around it. So the formula for curved surface area for cone is pi RL, or the formula for lateral surface area of the cone is pi RL. The formula for total surface area of the cone is total surface area of cone. It's the lateral surface area, which you call as a curved surface area, pi RL, plus the bottom circular lids area. Okay, that is pi r square. And yeah, after taking pi common, r common, we write the final formula as a pi r common, and we are left with L plus r. Okay, so this is the formula for cone. And yeah, now just the last formula, which is a sphere. Then we can start solving the questions. Volume formula I'll be showing you, but today let's cover this all the surface area formulas, and then let's solve the questions. So the next one is surface area of a sphere. As you understand, a spherical shape you have learned from lower classes itself. So football, orange, these are the example of a sphere. Okay, if we are having, suppose a football like this, there, okay, in there is a hanging point inside the football. Okay, exactly in the middle inside the football there is a point which is hanging just anywhere in the air, and that point's distance from each point of the football will always remain same. That point is called the center of this sphere. And the formula for surface area of the sphere, in a sphere we don't have so many surfaces. If you will touch and you will feel there is only one surface, that is called curved surface. So you call it curved surface, you call it total surface. This is only one surface we are having, the curved surface, total surface, whatever you call it, call it. The formula for curved surface area of the sphere is 4 pi r square. Okay, and the formula for hemisphere. However, when I'll cut this sphere in two parts, there will be hemisphere like this. Okay, hemisphere means exactly just the half of the sphere. Here we are having the curved surface area and the total surface area, because the moment we are cutting it, we can clearly see a circular portion. So it can be hollow just like a bowl, or it can be solid and this circular part can be filled, okay, or maybe covered. So for hemisphere, curved surface area of the hemisphere formula is curved surface area of hemisphere is the sphere's formula divided by 2. That is 2 pi r square. Okay. And the total surface area of hemisphere is the curved surface area plus this circular lid's area. Total surface area of hemisphere is this curved surface area plus the circular lid area. And hence the formula became 3 pi r square, and we are done with all the formulas for surface area. One thing I want you to understand, that surface area means area of all the surfaces added together. Whatever surface you are feeling, all the surfaces areas added together is called the total surface area. So if we will be having different types of shapes, combination of solids, we will try understanding how to find the surface area. Let's see the questions. These were just the formulas. Okay, formula you already knew, right? Right.
Yes, ma'am.
And these are the questions. Initially it is given that you can use pi as a 22 by 7. First question, two cube each of, wait, yeah, two cubes are there. Each of volume 64 centimeter square. What is the formula for volume of the cube? Yes,
AQ.
a cube. Okay, side cube, a cube, whatever you say. So volume of the cube, if you are thinking, but I am, okay, still I have not explained you volume. So this exercise is completely based on surface area. Yeah, meanwhile they will give you volume here and there by taking the consideration that you know everything, surface area, volume. Okay, you have learned it in the previous class. Don't worry, I'll be reminding you the formula along with the questions. So yes, side cube, a cube, this is the volume formula for cube. Find the surface area of the so two cube of volume 64 centimeter cube are joined end to end. Two cubes are joined end to end. Okay, just like this, like this. Let me take different color. Can you see how it is joined end to end? Two cubes, each of volume 64 centimeter cube. So if the volume is given as a 64 centimeter cube, we will be able to find the side of the cube. Okay, and the side of the cube will be 4 times 16, 4 times 64, 4 centimeter. Two cube each of volume 64 centimeter cube are joined end to end. So both the cubes are exactly same. Having side 4 centimeter, joined end to end, just like this. Okay, find the surface area of the resulting cuboid. Resulting cuboid's surface area we have to find. Can you see now it is nothing just a cuboid. Can you see the cuboid, a bigger cuboid? Yes or no?
Yes, ma'am.
Everyone, can you see it? Both the cubes attached together became a cuboid. Yes or no? Yes, Rayan. Are you getting Samya? Is it
Yes,
making
ma'am.
sense? Okay, Inan, is it clear? Both the cubes attached together became a cuboid. Can you see the cuboid? The length of the cuboid is nothing but the length over here, okay, and the length over here. I mean 4 plus 4. That is 8. The width of the cuboid is just 4, just like the cube 4. And the height of the cuboid still same, just like the previous cube 4. So the breadth is 4, height is 4, but the length of this cuboid is 8. Clear? Clear?
Yes.
We have to find the resulting, find the surface area of the resulting cuboid. Surface area we have to find. Please find it.
Ma'am, 160 centimeter square.
160 centimeter square. Everyone getting the same answer?
Yes, ma'am.
Okay, Afrin. Okay, Rayan. Yes, Inan. Are you done with this one? Have you completed?
Yes, ma'am.
Is it clear so far?
Yes, ma'am.
Okay, let's continue with the next one. Next question. Can you see this screen?
Yes.
Yes, ma'am.
This question number 2 says that a vessel is in the form of hollow hemisphere. Hemisphere looks like this. And hollow hemisphere means, okay, there is no, this top part is completely, it's hollow from here, just like a bowl. Okay. So a vessel is in form of hollow hemisphere mounted by a hollow cylinder. Mounted means, okay, on the top of this, there is a hollow cylinder like this. Okay, you are having a hemisphere, and on the top of that, you are having a cylindrical shape like this. Like this. Okay, a vessel is in form of hollow hemisphere mounted by a hollow cylinder. The diameter of hemisphere is 14 centimeter. Diameter of hemisphere is given as, the diameter of hemisphere is given as 14 centimeter. It's the diameter. Okay, as you understand, when we solve question for right circular cylinder, right circular cone, not any random cone, not random cylinder. Okay, I was telling you the radius over here, the radius, okay, all the radius, I mean the diameters will always be same. So with the help, since it is written in the question that diameter of the hemisphere is 14, we understand this is not just for hemisphere, this is for cylinder as well, because both are fitted. Okay, like on the top of the hemisphere cylindrical shape is there, and both are hollow. Okay, the diameter is given as a 14, and the total height of the vessel is 13 meter. The complete height of this vessel is given as a 13 meter. Find the inner surface area of the vessel. Okay, inner surface area, both are hollow. If both are hollow, you don't have anything. I told you, you just try realizing uh, what are the surface you can feel. And here, if you will try feeling, you will be able to feel inside. You will be able to feel there is a cylindrical shape, and below that there is a hemispherical shape. So basically you have to take the total area is nothing but total inner surface area. It's nothing but surface area of curved surface area. Cylinder plus curved surface area of hemisphere. Making sense?
Yes, ma'am.
Curved surface area of cylinder formula just now we have seen it was 2 pi rh, and curved surface area of hemisphere, half of the sphere's formula, that means 4 pi r square, that half, that means 2 pi r square, right? Right. Now for
Yes, ma'am.
hemisphere, you know the diameter is 14, so the radius will be 14 by 2. That means 7 centimeter. Okay, so 2 pi initially was written, you can take pi over here as a 22 by 7. Radius, it's 7. For you already understood that for cylinder also the same radius will be there. So 2 pi r radii is same. But what about the height? Please tell me what is the height?
13 centimeter.
It's the height of the complete shape. Okay, it's not the height of the cylinder. This formula is for cylinders curved surface area. We cannot take the complete height.
The height, ma'am, the
Yeah, height.
height will be the total height minus radius, right?
Yeah, total height minus this radius of this hemisphere. Okay, because it's hemisphere. Just now I was showing you a sphere. Sphere means there will be center point, and okay, everywhere the distances will be same. That's called radius. So this is nothing but just the radius. This red one which I am highlighting over here, it's nothing but just the radius of the hemisphere, because I am taking the length from the center. Making sense? Which is 7. So the complete height is given as a 13. We don't have to take complete height. Why? Because 2 pi RH is the formula for curved surface area of the cylinder. You just need cylinder's height. Just cylinder's height. See carefully, here it is written the total height of the vessel. Which vessel? The vessel which is made up of a hemispherical shape, and on the top of that a cylinder. The complete height is given as a 13. Okay. So we will be taking 13 minus 7. That is 6. Is it 6? Yeah. Is it clear to all of you? Is it clear so far? You can take 2 into 22 by 7. You can take as a common if you want. 6, 7 times 42, 7, 7 times 49. You will end up having 2 into 22 by 7 into calculation. I understand you will be able to do, but tell me the concept is clear or not. And yeah, please
Uh,
do it. Okay, note it down.
572 centimeter square.
Yeah. Yes, everyone getting the same answer. Yeah. Afrin, you are also getting the same. So yes, is it clear?
Yes, ma'am.
Let's take the next one. Have you copied everyone the solution?
Yes, ma'am.
Yes, ma'am.
The third one, a toy is in form of cone of radius 3.5 centimeter. A toy is in form of cone. Let me read. Of radius this mounted on a hemisphere of the same radius. Okay, a toy is in form of cone of radius 3.5 centimeter mounted on a hemisphere. It's exactly the same question. Their cylinder was there, here cone is there. Yeah, mounted on a hemisphere of the same radius is given. Okay. The total height of the toy, again they are giving the total height because they know that you will be finding the curved surface, find the total surface area. So they understand that for finding the total surface area of this toy, total surface area of the toy, you will be finding the curved surface area of the hemisphere and the curved surface area, which we also call as a lateral surface area. Curved surface area of this hemisphere and the curved surface area of the cone. Okay, total surface area of toy is equals to curved surface area hemisphere plus curved surface area of cone. Now you will realize that curved surface area of hemisphere, that is fine. The formula is 2 pi r square and now you know r is 3.5. But what about the curved surface area of this cone? The surface area, curved surface area of the cone formula is pi r l. Okay, so radius we know, but L, the slant height, we don't know. Okay, but the complete height is given. Okay, the complete height is given over here as a 15.5 centimeter. Here also, exactly like the previous situation, you will be doing the subtraction of the radius to get just the height of the cone. You need to subtract only this much, which is nothing but radius, that is 3.5 centimeter. Okay, this much you will be subtracting from the total height. So 15.5 minus 3.5, 12 only. Okay, this 12 is the height of this cone. Okay, not random height, the perpendicular height, that h value you know over here, it's 12. Making sense? And you know h, you know r, you will be able to find the slant height so that you can proceed with the calculation. Making sense?
Yes.
Please do it. Find the slant height. L is equals to, okay, we know there was a formula which came from the Pythagoras theorem. Okay, that much explanation we don't have to give. We will just say we know that L square is equals to h square plus r square. Okay, our h is 12 square. You show how you are finding the h value. Okay, so you can also show that here h is equals to 15.5 minus 3.5, that is 12 centimeter. Then we are using this h to calculate the slant height. R square, that is 3.5. square. Please find the L value and do the calculation to get the final answer, because this type of question is only analyzing that are you able to understand what exactly the shape looks like, and the with the given data are you able to use it properly, and if your calculation part are you able to do the calculation quickly or not. Only that this chapter will be analyzing that, okay, the concept is clear to you or not, and the calculation you are able to use on do it quickly or not. Just that pi value you can use as a 22/7. Please do it, otherwise I will leave this one for later. So yeah, if you will tell me that later at your home if you will be able to do this one, you have understood the concept, I'll leave it. So can I leave it? Inan, Afreen, Rayan, and Samya, can I leave the calculation part? Will you be able to conclude the? Will you be able to finish this one?
Yes,
Uh,
ma'am.
Yes, Rayan.
I did also.
Okay, you did. Okay, then you are done. Yes, Inan.
Yes, ma'am, you can leave it.
Okay, Afreen, you are also done. So yeah, let's do the next question, number 4. A cubical block of side 7 centimeter. A cube we are having. Let me draw a cube. A cubical block of side, the length of the side is 7 centimeter, is surmounted by a hemisphere. Okay, it's surmounted by a hemisphere. Like this. A cubical block is surmounted by a hemisphere. Okay. Uh, what is the greatest diameter of the hemisphere can have? See, this hemisphere is surmounted on the top of the cubical block. And the question says that what can be the diameter of this hemisphere? What can be the diameter of this? Okay, the diameter of this hemisphere. I am drawing the circle bold so that you can understand how exactly the diameter will look like. See, if you will take a cube, okay, if you will take a cube, say box or anything, you will take a cube, and on the top of that if you will place a bowl, okay, and if you will try placing it diagonally, no, actually it will not be able to completely, this hemisphere will not be able to just come on the surface. Are you understanding what I'm talking about? We won't be able to adjust a bowl completely diagonally, we won't be able to adjust. If you are